Hi everyone, in this video we'll be looking at matrices. So matrices is one of the topics that comes in the last question in a CXC paper 2, right? And it comes with vectors. So the last question is split up, half is on matrices, half is on vectors. And matrices is actually pretty easy. Once you go through it, it's to me, it's one of the easier topics. What you just take your time and go through it is one of the easier topics to get your marks in, at least in that second section. But you have to do all the questions in the paper, but sometimes it's a nice question to get a couple of marks easily, right? All right, so first of all, what is a matrix? So a matrix is a set of real numbers or letters that are arranged in rows and columns to form a rectangular display which is enclosed by a curved or square bracket. So they say curved bracket like that, or sometimes they use square brackets. Most commonly we use the curved brackets, right? So what are some examples of matrices? So as we said, it's basically curved brackets, and they have numbers arranged in rows and columns. So the first one we have here is 1, 2, 7, 5, right? So now the rows, remember a row is the horizontal, right? That's rows. And the vertical alignment, that's columns, right? So here I have two rows here, and then I have two columns coming down. Seen it? And then number 2, this is another example. 2, 4, 6, 7, 8, 9. Here I have two rows, and we have 1, 2, 3 columns, right? And another matrix, we have A, B, C. Well, that's the first row, and then P, Q, R, second row, and then we have the 3 columns here. So some more examples of matrices. You could have minus 2, 4, 0, 1, 1, 2. You could have A, 5, 4, and X. This is the same examples of matrices, right? Now, the order for matrix. So, the order for matrix tells us how many rows and columns the matrix has. So, for example, here we have this matrix here. 2, 4, 6, 3, 5, 7. So here we have two rows. If you look carefully, two rows, right? Remember this coming across horizontally. Those are rows, right? So we have two rows, and then coming down we have 1, 2, 3 columns. So we have 2 rows and 3 columns. We write the order as 2 by 3. And this is how we say it, 2 by 3, right? Now we always write the number of rows first, and then we write the columns after. So it's always number of rows by the number of columns. So if it's 2 rows, like in this case, so it's 2 and 3 columns, 2 by 3, right? So this here is important to note. The order of a matrix is number of rows by the number of columns. So here we have some more examples with the order of stating the order of a matrix. So number 1, we want to state the order of this matrix here. So looking carefully, we have how many rows? 1, 2, 3 rows, and 1, 2 columns. So 3 rows and 2 columns. I remember you write it as the number of rows by the number of columns. So this first one is a 3 by 2 matrix. That's the order of the matrix. Like in example 2, we have 1, 2, and 2 rows, and we have 1, 2 columns. So this is a 2 by 2 matrix. And then number 3 here, we have 1, 2, 3 rows and 1 column. So this is a 3 by 1. That's the order. And number 4, so let's take our time and look at number 4. So number 4 has 1, 2, 3 rows and 1, 2, 3 columns. So it will be a 3 by 3 matrix, right? That's the order. Now, there's some here for you to try by yourself. Pause the video and try it. State the order of each matrix. So pause it, and when you're ready, just play it, right? Alright, so let's cut it. I don't know why the numbering is off. The numbering is off. So it should be 5. This should be number 6, number 7, number 8. Sorry about that. Alright, so First one, we have 2 rows, so 2 by 1, 2 columns, so it's a 2 by 2. Number 6, we have 1, so 2 by, how many columns? 1, 2, 3, 2 by 3. 3 rows, 1, 2, 3 rows and 2 columns. So this is a 3 by 2. And last one, we have 1, 2, 3 rows, so 3 by 1 column. Alright, so pretty simple. Number of rows by number of columns. That's how you state the order of any matrix. So now let's look at, there are different types of matrices. And it's good to know the different types of the matrices that there are. So the first one we have is a square matrix. A square matrix, just as the name says, remember a square, think about a square. A square has 4 equal sides, right? So all the sides are equal. So in a square matrix, it has the same number of rows and the same number of columns. So some examples of square matrices would be, here we have a matrix A, 2, 4, 1, 6. There are 2 rows, 1, 2, and 2 columns. So it's a 2 by 2. The order is 2 by 2. We have the same number of rows and columns. In matrix B, we have 1, 2, 3 rows and 1, 2, 3 columns. So it's the order is 3 by 3. We have the same number of rows and the same number of columns. So therefore, both matrix A and matrix B are square matrices because in each case they both have the same number of rows and columns. Alright, so now we have a column matrix. So a column matrix is a matrix that has only one column. You could have a million rows. Once you have one column, it's a column matrix. So for example, A, matrix M, we have 3, 5, 1. So there are 3 rows, 1, 2, 3 rows, and just one column. The order is a 3 by 1. There's only one column. So it's a column matrix. And then the second one, matrix N, 0, negative 8. There are 1, 2 rows and 1 column. The order is 2 by 1. Again, only one column. So the two matrices are column matrices because they only have one column. Pretty simple. And now we're going to look at a row matrix. A row matrix is just like the column matrix. Is just, we deal with a row now, right? A row matrix is a matrix that has only one row. Again, you can have a million columns. Once you have one row, it's a row matrix. So in matrix A, in part A here, matrix A, 0, 7, negative 5, we have one row but 3 columns, right? 1, 2, 3. So the order is 1 by 3. One row, 3 columns, it's a row matrix. And then for matrix B, we have one row again, 2 columns. So the order here is a 1 by 2. Again, the two matrices here and here have only one row. So therefore, there's a row matrix, right? So far so good. Now we're going to look at a 0 or a null matrix. As the name says, 0 or null, meaning there in a 0 or null matrix, all the elements, all the members in the matrix are just zeros. It's just zeros inside. You won't have any other number but zeros. So M, 0, everything is zeros, 0 or null matrix. Matrix N, or everything is zeros inside, 0 or null matrix, right? Once it has only zeros, very simple, 0 or null matrix. And then the last type we're looking at is an identity matrix. Now, the identity matrix, we call it I. And if you look carefully, the first diagonal, meaning here, right? The first diagonal are ones, and the second diagonal is zeros. This is a standard matrix, doesn't change. So 1, 0, 0, 1, that is the identity matrix. The first diagonal is 1, and the second diagonal is zeros, right? So it's something to remember, and we'll look at it later on, right? We'll refer to the identity matrix later on. All right, we have a small little exercise here. Again, you could pause the video, try it, and then play when you're ready to get your answers, right? And let's just change the color for this video here. All right, state the type of matrix. So state the type of matrix in each of the following. What each of the following matrices are. Whether square, column, row, 0 or null, or the identity. So part 1, A, only zeros. So this is a 0 or a null matrix, right? All right, number 2. Here we have 7, 21, 5. We have how many rows? What's the order? 1 row and 1, 2, 3 columns, 1 by 3. So it only has 1 row, so it's a what? Row matrix. Number 3, we have 2 rows. The order is 2 rows by 1 column. So 1 column means it's a column matrix, right? And then last one, let's take the order here. 1, 2, 3 rows, so 3 by how many columns? 1, 2, 3 columns. So we have the same number of rows and the same number of columns, so it is a square matrix. So very easy, and in our next video we're going to get into more of the meat of the stuff in matrices, addition, subtraction in matrices, and later on we'll do multiplication and so on.